Okay guys, here's 6.3 notes. This is really very simple. We're still talking about parallelograms, and we're proving that this four-sided figure, that they are parallelograms. So like in this first example, it says, tell whether the quadrilateral is a parallelogram, explain your reasoning. Well, you notice it's marked with tick marks, single here, double, and a double. This theorem says if both pairs of the opposite sides of the quadrilateral are congruent, then it's a parallelogram. So in this case, let's zoom in here a little bit and take a look. Okay, you can see that if the opposite sides are equal to one another, marked by the tick marks. And since they are, then in this case, the answer is yes, it's a parallelogram because of this first theorem up here, 6.6. Okay, in example 2, all right, they're asking us to tell whether it's a parallelogram again. Now, this theorem is going to apply to this one. It says if the opposite angles are congruent, then it's a parallelogram. So here, take a look. So if you're at this angle, look across. Are those congruent? You have a double arc here and a single arc there. Double here and a single there. And it only takes one group to mess it up. So in this case, these opposites are not equal to each other or congruent, so your answer would be a big fat no. It's not a parallelogram. An example of that, if I wanted to draw one that was, would be simply look like this, and we'd say, okay, this side's equal to this side, and this side is equal to that side. That shows that the opposite sides are parallel to one another. Okay? In this next example, we're talking about consecutive angles. Consecutive means one right after another. Okay? So basically, again, we're just determining, is it a parallelogram? So it says if an angle of a quadrilateral is supplementary to both of its consecutive angles, keyword there is both for sure, then it's a parallelogram. So picture yourself standing in this guy's corner right here, all right, and he's 95 degrees. So you have to have the consecutive angles, whoops, I want the pen, not the highlighter, the consecutive angles right after that. And these both need to add up to 180. Okay, so you take 95 plus 85, that's 10, 180. So check. This one is yes, it's a parallelogram. How about this one? Let's take this angle, for example. We got to go this way and this way to the consecutive angles. So let's see here, 125 and 55. That's a 0, that's an 8. Okay, we check out this way. All right, it checks with these two, but will it with these two? Because this is 120, this was 125. If I add these two together, I'm going to get 175 degrees, which makes it a no, not a parallelogram. All right, they both have to add up to 180. In example 4, we're talking about the quadrilateral being a parallelogram again, and we're going to talk about this last theorem. If the diagonals of the quadrilateral bisect each other, and we talked about this a little bit in another section earlier this week, how when the diagonals cut each other in half, all right, then it means it's a parallelogram. So as you look here, let's look at this from J to L. Does this guy cut him in half? You got 19 here, 19 here, 18 and 18. So therefore, yes, that's a parallelogram. Look over here at B. Is this one cut in half? Well, you got 3 and 2 and 4 and 3. Those have all got to be equal. So therefore, no. Okay? All right. I did it in just under 5 minutes. That's 6.3 at 4 minutes and 58 seconds. Have a good day.